Oakley dokley. So now I'm going to talk to you about a different way of converting units. Okay? This is using proportions. Typically, we've been talking about using skeleton equations, but this is just another way. So the trick with skeleton equations is you always have to decide whether you're multiplying or dividing based on whether you are changing to a bigger unit or a smaller unit. But what if you didn't know which one was bigger or which one was smaller? Proportions is a way that works every single time. So, what a proportion is, it's a statement showing one ratio is equal to another ratio. So one ratio is equal to another. And we set up those ratios as fractions. So for example, 1 over 12 equals 3 over 36 is a proportion. It shows that one ratio or one fraction is equal to another. Alrighty. So let's talk about how to set up this proportion. So you're going to have two fractions. Now on this side of your fraction, the first side is going to be straight up from your formula sheet. Where the other side, this side here, is going to be from your question. All right, let's try that again. Q-U-E-S-T-I. Question. Cool. Now, whatever is in the same fraction has to be equal. All right, so these two things, the top and the bottom, they're going to equal each other. Just the same as these two things are going to be equal to each other. And whatever you have on top, these two things need to be the same unit. And the bottom two things have to be, they have to be the same unit as well. So that might look a little confusing. I'll show you a different way of writing it. So same unit on the top, same unit on the bottom. Top and bottom on one side are equal, top and bottom on the other side are equal. Right, so just another way of writing this. So if you had your two fractions, and instead of these random arrows, I'm going to put letters. So A, B, C, and D. Okay. So because A and B are in the same fraction, they are equals. So A and B are equals. Now, that's not saying that they're the same number, but we're saying they're the same value. For example, you could say 100 cents is the same as $1. The numbers aren't the same. 1 and 100 are different numbers, but they have the same value. So that's what I mean when I say equals. So C and D, because they're in the same fraction, they are also equals. Are equals. All right, just gonna make some room here. Now A and C are both on the top of the fraction, so they need to be in the same unit. A and C, they're the same unit. And B and D, because they're both on the bottom, they are the same unit. Spelling is difficult. B and D are the same unit. All right, so let's do some examples of using these proportions. So the first example is, how many kilometers are there in 3 miles? So first let's set up our proportion. So I'm going to need to find something on my formula sheet that uses kilometers and miles. Those are the two units I'm using. So if I look on my formula sheet, I will find that 1 mile is the same thing as 1.6093 kilometers. Right, so that's what's going to go on my first fraction. Okay, 1 mile is 1.6093 kilometers. Now the second side is from my question. I'm dealing with 3 miles. So my 3, because it's miles, has to go on the top. And I want to know how many kilometers that is. So this is what I'm looking for. So I'm going to call that, I don't know, I'm going to call it an X because that's really mathy. You can call it whatever you want. You can call it W, Z, you can call it happy face, you can call it a flower. I'm going to call it a flower. I changed my mind. So I've got one of those fancy smart pens. Bam. Alright. Oh, it's going to be flowers and X's. Oh, look at that. I don't care what you use for a variable, just can't be a number. Right, so that is my proportion. It's all set up. So now I just need to figure out what this flower X is. I need to get that by itself. So I like to do probably my favorite way to get rid of the fractions is to cross multiply. So when you're cross multiplying, you're going to take the top of one side times the bottom of the other goes on one side of the equal sign. So I'm going to put my equal sign here first. So 1 times x. 1 times flower power x. Okay, and the other side is going to be 3 times that. Top of one side times the bottom of the other. 3 times 1.609.6093. There we go. So 1 times x, well, 1 times anything doesn't change the number. So that's just going to be my flower power x by itself. On the other side, I've got 3 times 1.6093. I can't really do that in my head very well. I'm going to grab my calculator here. 3 times 1.6093. Boom. 4.8279. 4.8279. Now what is that? Is that 4.8279 miles, kilometers, cats, cows? Remember, whatever our unit was here on the bottom is the same as the unit is here. So that's going to be kilometers, which is what I was looking for. So that's my answer. We're all good. All right, let's do, I think I have 2 more examples. I'm just going to do one of them. You can do the other one if you'd like, or you can get me to do it in class. I'm going to do this one. Mei Li's house is 55 feet wide. What is this in meters? So again, I'm going to set up my proportion. So first I need to look on my formula sheet and I need to find something that uses feet and meters, feet and meters, feet and meters. I have on my formula sheet that 1 meter equals 3.2808 feet. All right, so that's what's going to go on my first fraction. So 1 meter over 3.2808 feet. And the other side needs to come from my question. So we're looking for 55 feet. So this time, I need to put the feet with the feet. So feet are on the bottom. So my 55 is going to be on the bottom. And I'm looking for meters. I'm not going to use a fancy X this time, just because it takes me forever to change pens. Alright, so now, same idea, I'm going to do my cross multiplying, because I don't really like dealing with fractions. So, I'm going to do top of one side times bottom of the other side, goes on one side of the equal sign. So that's going to be 1 times 55. Okay, now my other side is going to be top of one side times the bottom of the other, goes over here. So that's going to be x times 3.2808. Now 1 times 55, that's just 55. So I don't even need to write that. Now what my problem is I don't have x by itself. I need to get x by itself. That's what I want. So I need to get rid of this. I need to undo this multiplying by this 3.2808. So I need to do the opposite of multiplying. So the opposite of multiplying, or the inverse of multiplying, is dividing. What are you going to divide by? Whatever that number is that you're trying to get rid of, whatever is cluttering up the x or the variable. So I'm going to divide by 3.2808. However, because of math laws and math rules, and because you don't want to go to math jail, I'll do it to the other side. 2808. Whatever you do to one side, you have to do to the other. Now I got a 3.2808 on top and a 3.2808 on the bottom. They cancel out. All I have left is x. On this side, I have that 55 divided by 3.2808. And that's what I'm going to put in my calculator. So I'm going to go 55 divided by 3.2808. That's my answer. 16.764. X equals 16.764. What were we looking at? What is this? Cows, cattle, meters. So that's my unit. Okay, and whatever was on the top here would be the top here. So X has to be in meters. And that's my answer. Alrighty. Now remember, if you don't like proportions, you should still do these next practice questions using proportions, just so you get practice with them. But if you are a big fan of the skeleton equations, stick with them. Use what you're good at. But I still recommend trying some of these proportion ones out. Okay, my pen won't use proportions. There you go. I still recommend doing these with proportions. Anyway, let me know if you have questions. Let me know if you want me to do this example for you as well. Either way, have fun.